Hey there, welcome to day 19. We're going to do day 19 and hopefully it will go well. So, a series of tubes. So my network packet got lost and ended up here. It's trying to follow a routing diagram, but it's confused about where to go. Starting point is just off the top of the diagram. Lines show the path it needs to take, starting by going down onto the only line connected to the top of the diagram. It needs to follow this path until it reaches the end. Stop there. Sometimes the lines cross over each other. In these cases, it needs to continue going in the same direction and only turn left or right when there's no other option. In addition, someone has left letters on the line. These also don't change its direction, but it can use them to keep track of where it's been. For example, given this diagram, the packet needs to take the following path. Starting down, continues to the plus. Travel right, up and right, passing through B. Continue down, collecting C, right, up and right, passing through B in the process, continue down, collecting C, right and up, collecting D, finally go all the way F, find the path at the end. The little packet looks up at you, hoping you can find the way, while others will see if it follows the path. The routing diagram is very wide. Make sure you view without line wrapping. Okay, so it is very wide. Let me zoom. So it starts at the top and it goes, and we want it to go as far as it can until it sees, keep going until it sees a plus basically. When it sees a plus, it can go either left or right, and then it'll keep going until it sees a plus, and then it'll turn left or right. Okay, so let's think about this. And let's get this example. Starting point is just off the top of the diagram. Okay, good. So let's make this happen. And what was this one called? Day 19, a series of tubes. And I don't know exactly how we're going to do this, but we'll figure it out as we go. So test input equals and so let's think about this, and just let me make sure that that's right. Yeah, that looks pretty good. Okay, good. So and as always, I should put my doc string here. And so we're going to say, and we want to traverse a grid, and a grid is going to be a list of strings, and it is going to return a string. And so, and let's just say, let me make this raw test input, and then test, I'll just call it test input. And then I'll do test grid equals list row for row in test input. And so now let me IPython, and let's run day19.tubes. Name list is not defined. So from typing import list, and let's try this again, and test grid is K for row in test input dot split on new line. Let's try this again. So that seems to work, and our rows are not all the same length, but I think that's okay. And so to do the following. So we find the start, which will be the thing in the first row that has something in it, and then and direction is down, and then we go down, we go down, we go down. If it's a letter, we add it to our list, but we keep going until we reach a plus. We reach a plus, we look left or right, and then we keep going till we reach a plus, and then we turn again, and if we look down, there is no down, so we got to go up, 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 plus over here, down until we get plus. There's only one way to go, plus. Okay, so I think we can make this work. And and let me get named tuple. I always get named tuple. And I'm actually just going to call this state named tuple. And what is state going to be? It's going to be x is an int, y is an int, and direction, which is going to be, I'm just going to do a string, and this is going to be up, down, left, right. Okay, and so what do I want to do to traverse this? Well, first I'm going to say you know, top row equals grid 0, and then I want to find initial column equals top row dot, so let's say test grid 0 dot, is index right? Yeah. Top row dot index of this pipe, and I think we've decided that that'll always be, and you know, state equals state, and x is initial column, and 0, and then direction is down. Okay, and let's go, and we need to until it reaches the end and stop there. Okay. And let me add a couple of helper functions. And next cell, given a grid, which is a list of strings, and a state, which is a state, and it's going to return and you know what? Actually, I'm going to do letters, which is going to be a list of string, which is going to be this. So actually, no, I'm not going to do default value like this. I'm going to do this, and so I'm just going to keep track of the letters I've seen. And I'm just going to call this step, and it's going to return another state. And so I also want it to, I'm just going to do finished bool equals false. While not state dot finished, state equals step grid comma state, and then at the end I want to return, I would just want to join the state dot letters. So I think that that works for traverse, which means we need to write the step function, and of course the step function is going to be the hard part. So what do I want to do? I start with a state, and I'm going somewhere. So if okay, so x equals state x, y equals state y, direction equals state dot direction. And so what do I want to do? You know, to start with, I'm in 0 and I'm facing down, and I want to go. And so I need to think, I guess I want to, and so let's say current equals grid xy. And so if current in, so if it's one of, you know, these guys, then, and were these all uppercase letters? Was that right? Or lowercase letters? Uppercase letters? They're uppercase letters. So if that, then I just want to keep going in the state, or in the direction that I'm in. So if, you know what, I just want to modify the state in place. So rather than doing it this way, init.self, self.x, actually let me do x is int and y is an int, and direction is a string, self.x equals x, self.y equals y, self.direction equals direction, self.letters, which is going to be a list of string, just equals an empty list, and now I won't need a track finished, because what I'm going to do is just return a Boolean here and modify the state in place. And so while step grid comma state pass, so that's, yeah, I think that'll work. Okay, so what do I want to do? If direction equals up, and you know what, I'm going to call these up, down, left, and right, because that'll be easier to read. If direction equals up, then state dot y minus equals 1, and return elif direction, and this is probably not going to be the most efficient way to do all of this, state.y plus equals 1, return, and return false, not, no, return true. I want to return true if we're not done. Return true, elif direction equals left, state.x minus equals 1, return true, elif direction equals right, state.x plus equals 1, and return true. Okay, so that's going to deal with those cases. Okay, and you know what? I'm actually going to I feel like I want the grid to be part of the state too. And so grid list string, and self.grid equals grid, and then I can just step on the state, and while step state. So I feel like I want to add helper functions to the state. And so what happens if I run this? I think it will break. No, it won't break. Okay, good. So that's fine. Elif current in from string import ASCII uppercase. And now I want to move this over here. So def go forward self. So I'm just going to move this over here because I want to use it multiple times. So if self.direction equals up, self.y minus equals 1. Otherwise, if self.direction equals down, self.y plus equals 1. Otherwise, if self.direction is left, self.x minus equals 1. Otherwise, if self.direction equals right, self.x plus equals 1. So that's just go forward. If current is in that, state.go forward and return true. So otherwise, if what I was going to do is ASCII uppercase, elif's current in ASCII uppercase, so if it's an uppercase letter, and you know what, I don't want to do that. Elif a less than equal to current less than or equal to z, then I'm going to do two things. One, I want to state dot letters dot append current, and then I also want to state dot go forward, and then I want to return true. Otherwise, if current is the plus sign, then I want to do two things. I want to do a state dot turn and then state dot go forward. And I want to do that because once I turn, I don't want to stay where I'm at, because then I'll turn, I'll just keep turning, and then also return true. And then otherwise, nothing to do, return false. So the only thing left is we have to do this state.turn, and I think that's the one that's actually going to be a little bit tricky. So def turn self, and so how do I turn? Okay, so let's say if self.direction equals up. Okay, so I'm going up and I want to turn. And I need to know whether to turn left or right. So let's and so when do I want to turn left and when do I want to turn right? So if I'm facing up, try on my left equals grid self dot x minus 1 self dot y, except, and you know what, let me write this try logic, def get x int y int, and it's going to return an optional string, and that means I need optional. And so let me do one thing. X equals 1, 2, 3. X5 is an index error. X minus 1 is not an index error. So that's a little bit bad. So we'll have to get that logic in. Okay. So if x is less than 0, return none. If y is less than 0, again return none, because I'm trying to look off the board, which is bad. If if y is bigger than or equal to len self.grid, which is the number of rows, then I'm going to return none. And if x is bigger than or equal to len self.grid y, and I'm calling these x and y, but really, I need to replace these x's with i's and j's, because otherwise they're not good. Self.I equals I, because x makes me think side to side, and this way I'll be using them correctly. And get I, j, if I is less than 0, if j is less than 0, if I is bigger than or equal to the len of the grid, and if j is bigger than or equal to the len of the grid I, return none, and then otherwise I want to return grid I, j. Okay, so and I need to fix these I and j equals state I, state j, current equals grid I, j. That's fine, that's fine, that's fine, that's fine, that's fine. Okay, so now I still need to do this turn function. If self-direction equals up, then on my left equals self.get, why is it saying j, comma int? Self.I, self.j minus 1. I'm sure I'm screwing this up. Right, equals self.get, self.I, self.j plus 1. And now, what did this grid look like? So I actually want to I'm actually going to return .strips. That way I get empty strings if they're empty. And so then, actually I think what I can do is if self.direction equals left, else self.direction equals right. So else self.direction equals down, and I think I can actually do the same thing. So if I'm going either up or down, doesn't really matter, then I'm going to check over to my left, and if there is something there, then I'm going to set my direction to left. If there's not, I'm going to set my direction to right. Else left or right, if self.get self.strips I minus 1 self.j. So if I see something basically above me, self.direction equals up. Otherwise, self.direction equals down. So I haven't checked every case, but traverse test grid. So there's a very small chance that it will work. And it takes 5 positional arguments, but 6 were given. So I don't need to give it the letters, I guess. Is that right? Grid ij direction. So grid ij direction. Name grid is not defined. State.grid.i.j. That's really interesting. So it didn't much do anything. Print state.dict, and let's see what happens. That still did not do anything. So that state works. So we got to go into step, and let's print current. And so that is not right. And because I need this to be 0, comma, for the row and initial column second. So this is where I got mixed up by switching x's and y's to i's and j's. So current I equals 0, j equals 6, direction equals down. Print state.dict. And so let's run this again and see what happens. State there is current there, and I0, j is 5, and then direction down, I0, j is 6. So go forward. Okay, well, now I've got these backwards too. Let's try this one more time. Get takes 2 positional arguments, but 3 were given. Okay, so get, that means I forgot to type self, and let's try this again. Grid is not defined, so that's inside state, so let's type the self. Let's run, and now it got A, B, C, D, E, F. So that so I just want to print the current, and let me pull up this now, and so it goes tube A, tube plus B, minus plus vertical, skip over the slash, do C, all the way around to D, all the way over to E, F, and then stops. So wow, that seems to actually work. So good. Let's try it on this new puzzle input and see if that works. Save. That didn't work. Save link as day 19 input.text. And let me just do assert that traverse test grid equals A, B, C, D, E, F. Okay, if name is main with open day 19 input.text F, raw equals f dot read dot strip. Grid equals list row for row in raw dot split on new lines, and print traverse grid. Okay, good. So let's run that and see what happens. And nothing happens. So print grid. Okay, I'm going to comment this out and let me run it one more time. And it's saying current is that, and then current is over. So that seems very wrong. And let's take a look at it and see why it's wrong. So I start there and I go down and it should be there, and it should keep going, and it should keep going. Okay, so it seems pretty well formed. So let's try and figure out. Oh, it zoomed out for all this. Okay, so print ij current. So let's run this again. Okay, so 0, 0 current. So this 0, 0 is definitely not right. And that is because, why is that? Print initial column. So that seems wrong. So let's look at grid, and let's look at grid 0. Grid 0 dot index of the pipe. Seriously? Grid 0, 0. Grid 0, 0 is a pipe. So why is that? Because when I stripped it, I got rid of the spaces from the beginning. So I actually just wanted to strip off the new line at the end. And now it ran, and so that seems more sensible. And let's put that in and submit it. That is the right answer. Okay. The packet is curious how many steps it needs to go. For example, using the same writing diagram from the example above, the packet would go 6 steps down. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. So it seems like it's just counting the steps, right? And okay, so if I do like num steps equals 1, num steps plus equals 1, and so every time we do a step, actually let's start with num steps equals 0, and so every time we successfully take a step, let's add 1, because at some point we're going to get to an empty one and we don't want to count that. And print num steps. And so now let's just do this and check it on. So that says 38 steps on my test input, which is right. And now I can run it this way, and it's saying that I did 16,764 steps. It's a lot of steps, but it's what I calculated. So that is the right answer. So here is the odd case where once you've done the first part, the second part is like not hard to do at all. So good. I'm happy about that. And it still took me half an hour, but you know, half an hour is better than an hour. So I hope you enjoyed this one. Find me on Twitter at Joel Grus. Tell your friends to watch the video, and I'm happy that one went well, and hopefully they will keep going well. See you next time.